Okay, so we're back on. Now we're going to continue with the wind erosion. So this time the force, okay, the force, the force that causes all the movement of soil particles this time is no longer the water, but now is the wind. So it's the dry phase. Okay, you can say that this is the dry way of erosion without water, and the effect of this erosion is actually quite unique and quite different. Because what? Wait, if you want to have a wind erosion, first of all, you need to have a strong wind. That's number one. And number two, most people don't know, with strong wind, it only comes when you have a very flat landscape, very large land mass, like Australia. Okay, that's number one. And then the other one may be USA. And I think the one that has like very extensive erosion, wind erosion, will be Saudi Arabia or the Sahara Desert, because you can see like the entire continent, the top of Africa continent is so big. I mean, several hundred times of the size of Malaysia. The entire continent is flat. So those are the areas where you have extensive wind erosion. But anyway, we're going to talk about it because our East Coast, like Kelantan, Terengganu, and Pahang, they are so exposed to wind erosion that we also need to take note lah, yeah. So what is in wind erosion? Now, wind erosion also very similar to water erosion. It happens in three steps, but this time slightly different, with some slightly difference in the terminology as well. So the first step begins with saltation. No salt involved, but this one almost like the dislodgement. Remember just now water dislodgement, where some water particles drop from the sky, hit it with high velocity, and then boom, it comes up. This is exactly what happened. Only difference is it does not start with water, but some soil particles that's already airborne. Because why? When strong wind happens, guys, it blows up some lighter soil particles up, maybe sand, maybe clay particles. I don't think clay we're going to call saltation. Usually saltation happens when you have some particles heavy enough that flows up temporary, and when it comes down, they just move. They will behave just like the rainwater droplets just now. Comes down and boom, again, they're going to release and dislodge more soil particles. Yeah, so that's saltation. And then next is suspension. Suspension in the true meaning of suspension is something that is floating and does not comes down. Now this one refers to the so-called clay particles along with some strong wind, so they just swirling around because clay is so light. Whenever you have enough velocity in terms of wind, they just follow and then sweeps up very easily because they're so light. Yeah, this perhaps does not happen to sand, but sometimes you cannot imagine, in desert area, the wind so strong they can even blows up somebody with, say like if you're less than 30 kilograms, you will fly out in desert. I'm not kidding you, it is true. Some winds are that strong, yeah. And then the last one is surface creep. Now, surface creep is reserved for some larger soil particles. Cannot lift it, kan? When wind comes, you cannot lift it. They will roll. They will roll very slowly, and that itself will help the wind erosion. Because why? When this large particle rolls, they have mass. They're heavy, so they press down. And when they roll, the surface of these particles are not very smooth. They are edgy. So when it rolls on top of another hard surface, they have abrasion, bergeser, and this causes the erosion. See, so much difference, kan? So wind erosion happens when there's a wind carries another soil particles and rub against another soil particles, and that causes the wind erosion. So you see, that is the difference, lah, main difference. And these three terms, kan, it sounds so it looks so similar, but the difference is it doesn't contain any movement of water. So you can see that based on different particle size, the smallest one they suspended. The one that involved in saltation, sand particles, they are not very light but not too heavy, so they can lift temporarily, falls down, they cause saltation. And then the rolling creep or surface creep is due to the larger soil particles that cannot lift up, but they roll, they move along the surface. Yeah? Now, I believe you don't have chance to come to this one, except that you go to do Umrah or maybe Haji. Then this happens. Like it happens a few times like to Hajj pilgrimage a few years before, where sandstorm comes. So when this sandstorm comes, it's like a strong wind, and it blows like as high as the horizon can see, and the dust actually moves in. The entire sky actually turns to red color because of this airborne clay particles. Okay, influence of erosion. So we are done with the mechanics or the steps involved in wind erosion. I really did not show you the landscape as a result of this wind erosion because I think the result of wind erosion in Malaysia is obvious in some large landscape lah. Now, to say large landscape, Malaysia is not really a very flat nation actually. So the only way you can see the effect of this wind erosion is seaside. But then again, seaside also have another type of erosion. It's called the apa, akisan laut. It's the tides, the movement of tides, and also the waves coming from the sea. That also cause a lot of erosion. And for those who actually have friends study in University Malaysia Terengganu, the university campus like is one of the worst due to the ocean erosion. Now that one we're not going to talk about. It's due to some movement of tides, some waves that comes in. That's a completely different story. Although quite similar, but that's marine kind. We're talking about soil, so we're not going to talk about that one. Now for that, we are moving on to another part. We are going to discuss about the factors. What causes an erosion to happen more severely in some places? Because soil, as you know, they are not created equally. They might be created in different chemical composition, maybe different in elevation. Some of them they are created very high. So places at a high elevation usually will be more exposed to erosion because why? Water flows down. You have slope. That is one. So today we're going to discuss all these five layers: erodibility, surface cover, topography, climate change, and also the land use. So these are the main five factors. However, if you still remember when we first learned about soil science, you have been exposed to the weathering process and happens that they also have five factors. So these five factors sounded very similar to this one. Not exactly the same, but very similar. You're going to see the same factors once again later on. But first thing first, let's make sure you know the right meaning. Because here, there are two words that may confuse you. Erodibility or erosivity. Now, the one that you need to know right here is the erodibility, which means how easy a soil can be eroded. So that depends on how strong is your soil or how weak is your soil. Now, erosivity is the other way around. It no longer looks at the soil. It looks at how strong is the force that caused the erosion. So this one, how strong is your wind or how strong is your rain? How fast your rain will going to flow? So these are the two terms that you need to be sure of, but we're not going to touch too much about erosivity. This is more of like a geography and also meteorology. We're not going to learn about it. We learn about soil science, guys. So this word that we are going to touch a lot, yeah? Okay. So erodibility depends on the texture. Texture, what causes it? Distribution, okay? Distribution between sand, silt, and clay. Now, which one is the most durable in terms of erosion? We're going to talk about that. Now, with all this texture, it gives you a different structure as well. And let's not forget this one, organic matter. What is organic matter doing here? I think previously when we learned about organic matter in soil organic matter, I actually told you that organic matter helps reduce erosion. I'll explain to you later on. And then also permeability. Permeability means how easy the water can absorb into the soil. The higher the permeability, the lower the risk of erosion. So erodibility depends on the soil characteristic and also the soil texture. So without further ado, let's look at table 1. So this is table 1. What you can see right here is different soil series as well as their texture. Now, as you can see right here, with different texture from clay to loamy sand, I mean, from the top is the finest and the smallest one. And then when it moves to the bottom of the table, it becomes much more larger, much more coarse. More sand is involved. Now, what is that going to do with soil loss? As you can see right there. Soil that contains more clay is most likely to experience lesser soil loss. See, soil loss to erosion much lesser compared to the coarser one. But let's not forget, you also need to look at the percentage of carbon. Okay? Now, it's quite safe to say that with more carbon, you're going to suffer a bit more loss, but the most is coming from here, fine sand. So that series with the least carbon amount. What does that tell you? That tells you that with the least amount of carbon that you have, soil loss may be enhanced. So that actually consistent with what I told you just now. Soil organic matter helps reduce erosion. So this is one here. Now, if you look at this part here, clay. Now, you might be argued that how come clay, the smallest particle that can be easily float or removed by movement of water, can suffer the least soil loss? I think I need to correct you on one thing. This clay, perhaps in this situation, these clays are already absorbed with water. Now, clay, if on top of the clay you have a thin film of water, that thin film helps protects it against erosion. But of course, this thin film must be very thin and it does not flow. If the thin film exists over there and it does not flow, that thin film is the protection of the erosion. Because why? You have thin film, kan? When you have rainfall coming down, it hits the surface. Remember, water have very high surface tension. So as if like when it hits it, it bounces off. It reduces the impact, the water film, we call it. However, if you talk about this clay without the water film, okay, this might be different. Okay. So the message that you need to know right here is that with more carbon, you'll get less soil erosion. And of course, the texture, if it is more, if it has a lot of aggregation, that means it sticks together. Usually that's also very durable against erosion. Okay, so as you can see right there, with more clay, it sticks together. Why? I mean, first of all, why clay sticks together? Because of water as well. Now, when you have water, it as if like it serves as like an adhesion. When you have small particles, a lot of small particles with enough water, not too much of water, just enough, they will stick. And this stickiness gives you aggregation. Aggregation means the soil particles sticks together, and when you have water movement, they don't tend to break up. However, if you have enough water, a lot of water comes in, this clay will still eventually be eroded. Yeah? So don't get yourself confused. Clay, they will have water, they cause aggregation. That's why. Yeah? That's why sometimes they have less erosion. But in reality, okay, I think I need to correct you one thing right here. Now, for those who have friends or your siblings who study in civil engineering, they were going to object my point over here. Because why? In civil engineering, what they learn, the most suitable soil material for construction is not clay, it's not. It is not. And I agree. Because why? In reality, do you expect that the rain will not come down? Of course they will. When rain comes down, the first thing to wash away is, of course, clay, which is true. And that is why in civil engineering, their most preferred soil particle for construction is sand, not clay. Because sand, when you have inundation of water, when it is flooded with water, sand will still be there because it's heavy. But if you have inundation of water on clay, you know what will happen? The clay will, number one, swell. After they swell, what happened? Then the building sinks. And then what happened? The clay will also follow the movement of water. So in reality, there are a lot of things that you need to know, yeah. So soil erodibility is due to that, yeah. Anyway, next point, soil surface cover. I mean, if erosion is caused by the lack of cover, then to reverse that, you need to add more surface cover just to protect it. I mean, this is not too difficult to understand. If you have a cover that protects it against the beating of rainwater, these, of course, will going to influence a lot on the erodibility of your soil. Because why? There's so many things they can do, okay? What a plants can do, okay? Number one, the plants begins with the tree top with a lot of leaves. First thing that they do during a rainfall is they're going to intercept the rainfall. So rain comes down in high velocity, hits the leaves. What happened? It reduced the velocity. So from that on, it actually helps reduce the energy, and it might going to decrease the dislodgement process, because with slower velocity, it hits it with some slower velocity and less soil will become detached. Okay, that's number one. The next one is it provides a rough surface. Now, what is this rough surface? Now, if you can imagine, when you're standing just below a tree, what do you see? Tree roots, kan? Now, when these tree roots, when they grow on top of the surface, they are not going to grow like uniformly. Sometimes it's higher, sometimes it's lower. So there's like, they have a lot of boundaries, that stops the rain from flowing very fast. That's what they call rough surface, yeah. They resist the formation of runoff, because runoff, they flow vertically, and when you have roots going on top, they stop it and they have to go around. So that reduces the velocity, actually. And then the third point, physically holds soil together. Okay, very easy. Which part of the plant that touches the soil? The roots, kan? That's why. The roots, if you can see some lalang, I mean the wild grass, maybe on the roadside. Once you pluck it out, you're going to see that those roots are actually very extensive. There are a lot of these roots, very fine, and they carry a lot of soil with them. So why they can physically hold the soil together is due to the presence of this root. They expand, and sometimes they have a lot of like tiny little networks that actually tie the soil together. Yeah. Okay, number 4, removes water from soil. Now, how does tree removes the water? I mean, come on, trees, what do? Photosynthesis. Where does the water comes from? From the root. So they absorb whatever the water that's in the soil, they absorb and they transpire. And then what happened to the soil? They become porous, so more water can be absorbed. So this encourages the absorption of water to retain it. Of course, when water is being absorbed, less water on the surface, then no erosion. Okay, last point, non-vegetative cover. Okay, now this one is referring to non-living things. It could be dead organic matter, or maybe it could be a stone or mineral. But sometimes nowadays, a lot of people, they're using mulching. It could be from organic or non-organic surface, non-organic sources. Plastics sometimes are being used as non-vegetative cover, but if you can choose, use organic. Because what? Mulch is from organic. They decompose. When they decompose, it slowly releases the nutrients. So mulch is usually the preferred choice rather than plastic. Plastic, after they degrade, what do you get? You get plastic. There's not nutrient yet. And then finally, aggregates and paving. So this one, use tar, bitumen, use tar oil. So this will going to form your root size. Now this one, technically, they are not natural. They don't give you nutrients, but they are quite effectively in stopping erosion. Now most of these aggregates and pavement are due to structure building. You build a lot of structure that includes roads, that includes pavement. I mean the roadside walkways that those are called pavement. Yeah, tepi jalan where you can walk on top. Those are pavement. And then the build of structures from buildings also counted as this one. It's not just road or pavement. Sometimes building also count. So different covers and different ability to have to have erosion. Without cover, you have a lot of erosion. And of course, you will going to look at what kind of surface cover do you have? Is it forest or is it cultivated crop? Now there's a very big difference between forest and also cultivated crop. There is a big debate last time when the environmentalists challenged Malaysian government back then. They say if you replace virgin forest with oil palm plantation, how sure are you going to how sure the then government can say that the erosion will never happen, and they're quite true on that one, because you know what, when the forest is being replaced, even though that the new crop can be brought up in very short time, the difference is that this crop is not as efficient in covering the soil. Okay, I give you one example. When you want to have agriculture, they will have a minimum distance, because when crop are planted into a farm soil, if you plant it too close together, your crop will not become very big. It's not productive. As a result, in agriculture, usually every crop, when they plant it on a piece of soil, they will have a minimum space. And this minimum space ensures minimum competition among individual trees next to each other, so that they don't compete for nutrients and also some other things like water source as well. And do you know what's the problem? When you have such a small distance, these distances are not covered. And then guess what? Yeah, erosion. There will be some gaps. There will be some gaps where initially when crops are being brought up, these gaps are not covered by any trees, and these are the areas that you get erosion. Yeah. So, but then again, when you look at crops, there are so many types. Some of them like permanent trees. Why I say permanent trees is like rubber. You don't see people chop down rubber trees so often. What do we do to rubber trees? We just tore. We just cut the outside bark so that we collect the latex. We don't chop down the entire trees. We leave it live. By the way, rubber trees and palm oil trees needs to be chopped down every 30 years. So in these 30 years, you don't do anything, just let it grow. Kan? However, if you look at paddy and also annual crops like your jagung, your maize, your groundnut or your tobacco, you remember how people harvest this crop? They just chop down the entire plant. Because why? Like for example, like your groundnuts, where do they live? They live in the grounds. And then your ubi kayu, for example. Your ubi kayu, you don't just simply cut one small ubi kayu and let the entire tree grow. You just pluck the entire ubi kayu. So what happened? There's no longer surface cover. That's a problem. See, in agriculture, it depends on what you plant. And based on the different crops that you plant, it will have a different degree of erosion to the soil. So basically, what people prefer in order to reduce erosion, rubber trees or oil palm tree. But here's the thing, rubber trees and oil palm trees is not foolproof. If you compare rubber and oil palm to virgin forest is still the best in terms of covering the surface of the soil. Not even rubber and oil palm can do it. Because why? Remember forest just now? They have 3 layers. Rubber, just 1 layer. Oil palm, 1 layer. You see, the 3 layers give them very complete protection against erosion. So I think I leave it to you at that and go straight to topography. Now, topography refers to the shape of the earth. Now, just now you know that water flows from high ground to low ground. And then the erosion will be magnified, made more severe if the rain flows very fast. So you already know the answer, kan? Slope is definitely one. The more steeper the slope, the worse the erosion will happen. But there's more. Let's see. So here, the steepness. I think I already explained to you. The more steep the slope, the faster the water can flow down, and that's why more energy will be able to carry more soil during the erosion. However, I think wait a minute. This is still about the degree of slope. This is just a conversion. So I'm going to skip straight to another one. Yeah, this one. Now, there's one more factor in topography that not many people know. Now, in this case, they are saying that another factor apart from slope is the length of the slope. That means the longer the slope, the more erosion will going to happen. So you might be asking me, how come this happened? Okay, well, here's the thing. Let's say, I believe you watch a lot of cartoon. You watch a lot of cartoon. You remember what happened if you have a small snow rolling down? Eventually it becomes bigger, kan? Okay, this is the analogy I'm trying to use. Let's say if you have a small clay particle started rolling from the top of the hill. Eventually, when it comes down to the foothills, it will carry a lot of other soil with it, because when it rolls down, it's just like the surface creep. Remember just now, they roll, and when they roll, they carry along with other soil particles. So that's why the longer the slope, the more erosion will going to happen. Okay, so these are the ones. Now, the third factor, the shape also may be different. So just now we talked about the slope, the steeper, the worse erosion, the longer the slope, the worse erosion. But this one is the shape. Now, how do we differentiate these two shapes? We have two. It either can be identified as convex. Convex is bulging. Bulging means like this. Like this. Okay, imagine this surface. Okay, bulging means it's like one cone, one dome covering that surface. Versus concave. Concave is like, yeah, it's like a cavity. Okay, imagine this surface. A concave means there's a cavity going down and up again. So that is concave. Bulge, concave. Okay, now, which one that is more exposed to erosion? The answer is the convex one. They say convex will be more exposed to erosion. Okay, now here's the explanation. It is said that the soil convex dries out readily on top. So when they dries, they don't tend to have a lot of vegetation. So even though they are like quite flat at the top, they're bulge, they're quite flat at the top. But because the top are so, they have slope going down, they don't usually retain moisture. And as a result, it's unlikely they're going to have enough surface cover to cover it. And because of that, they don't produce too much of carbon. With less water, nothing will survive, and you don't have enough carbon. And that we're going to have like a chain reaction to it. Because if you don't have enough carbon, remember just now, carbon sticks with the soil. They increase aggregation. No carbon, no aggregation. That means on top, it usually happens the most severe erosion. Now, contrary to the other one, the concave one, you know why concave usually have less severe erosion? Because you have a U shape, for example. At the bottom of this concave, it usually retains water. So when they retain water, they, number one, will have thin film of water. Kan? Remember just now, thin film of water, they stop the beating. They reduce the beating. That's number one. Number two, when you have thin film of water, it have enough moisture to have vegetation. See the difference? If you have moisture, it retains vegetation. Even though all moisture comes down, all rainfall comes down to the same place, it's not going to have so much of severe erosion because they have enough cover, surface cover, the vegetation to help reduce erosion. Okay. I hope you can answer this question, yeah. For those who have see past year exam question, you will know how question will be asked. So I'm firing some warning shots to you. I'm not going to give you tips, but here is my tips. Go see past year final exam question and you understand why a lot of your seniors actually struggle with this question, because they hafal essentially. So don't hafal, don't plain memorize. I want you to able to explain this shape and this shape, why these two have different severity in erosion. I think we are coming down to the last 2 points. Climate. Duh, I mean, if you have wet climate, you have more erosion, because that's where the force coming from, apart from temperature. Yeah. I mean, very extreme temperature change also may also cause more severe erosion. And then last one, land use. Land use usually is associated with a lot of human activity. It depends on what you use. If you say the land use is to cultivate, if is to cultivate some trees that gives you crop like fruit trees, of course, erosion will be less. But if you compare another agricultural activity like planting cassava, your ubi kayu, every season you have to clear the land. Of course, now erosion happens a lot. So it depends on what people use on the land. If people can maintain the surface cover, usually that will going to reduce the erodibility lah. Okay, I think let's finish this one. I know I think I already passed 30 minutes, but I think I want to finish this because I think this is the last few slides. Let me finish lah, yeah. Okay, let's talk about climate. Northwest. Which place is the wettest? Right here. I think I will show it to you just now in the map. So I think I'll skip this one. The driest place is right here. Negeri Sembilan, Gemas, to be exact. These are the towns that have the least erosion, but also not too fertile because not enough water. Right? Okay, prediction of soil loss. This one I think I will not going to talk too deep. I just will skip through. So this is the formula. Now, this soil loss prediction model, um, us, I don't think is so applicable. Because why? Because usually this model, okay, this model is developed by USDA, not mistaken, US Department of Agriculture, because they have a lot of very vast piece of land. And their farmers actually need to realize, what happened to the soil. Not only they just put fertilizer, they also need to know that is there any erosion happen on their farmlands. And by using this formula, they can kind of estimate, okay, the severity of soil loss. Because when they have soil loss, then they have to do something like either taking topsoil from other places and replace it, or maybe have to change the way they manage the soil. Because if you look closely, this RKLSCP represent a lot of things, and they actually mimics the factors that cause erosion. Almost the same. It's just this one, they put it as a formula and they come up with an index, a value. This E value is said to be an index under this formula, and they have a value to compare. If it's too high, what do you need to do? If it's too low, it's good. Because usually if it's high, that means a lot of soil is being lost. Then they have to do something like where is the problem and how to find the solution. And with that, I don't think I want to explain again the factors, because these are usually used by farmers to conserve their soil. Okay, so I'll skip through here. This one you can look at it because I don't want to repeat what I said to you just now about soil erodibilities. More or less the same actually. Okay, so I skip through the less important part. I didn't say it's not important, so go through, yeah? Okay. So this is the last part. What problems caused by erosion? Just now you saw a few slides. Tanah runtuh, landslide, kan? Okay. Now, erosion, let's generally speak, apart from loss of property or damage of property or loss of life, majority of the problem happens in erosion, also involve other things, not just the loss of fertility. It also causes this one. Because when soil and also nutrient is being washed away, the soil becomes less fertilized, less fertile. But these nutrients have to go somewhere. Where do they go? They might go to river. They might go to lakes. They might even go to the sea. Now, this nutrient, silap hari bulan, when they end up in a lake, they will cause eutrophication. I'm sure you know what is that. It's one example of water pollution. You see, one erosion causes two problems: the soil problem and also the water problem. That's why taking care of erosion actually helps a lot because it will solve two problems. So offsite damage, what happened apart from the siltation, the damage, you don't have enough water to flush something, or you have too much of water that you cause the damage of landscape. So these are the plus things that I explained so many times, and these are the repeated points, so you can read it for yourself. This is the details okay? The details regarding eutrophication as a result of erosion. So go and read it yourself. Why I don't want to talk about eutrophication, because you learned it before in secondary school. but I don't know to explain. Okay, the impact of wind and water erosion on the surrounding environment can be reduced by. See, when you have erosion, what do you do to reduce the impact? I will skip this slide because why? There's another chapter that talks about this one. So I'll skip, yeah, okay? I'll skip because there's another chapter that talks about this one. And I'll show you this picture. Now, this picture is actually happens in Malaysia, 2008. Uh, I think you were not born still. Yeah. But however, now this one received a large coverage simply due to this is a classic example of human negligence. Human negligence that caused landslide so severe that it becomes an international news attention. Why? Because Astro Avani covers it. It has part one and part two. So after this tonight, you can go and watch it. That place lah, the Bukit Antarabangsa right now is the very famous site for paranormal investigation. But I mean, trust me lah. If you trust that one, there exists. But let's learn the science lah. Yeah. So through these two video, you will learn the fundamentals of erosion, how erosion happens, how negligence caused this, and this is a lesson learned not to be repeated again. Actually, however, you see, 2008 kan? What year today? 2020. How many years has passed? 12 years. Guess what? Look at Penang. The same thing happens once again. So for those who stay in Penang, have a look. For those who staying near Hill Slope, also remember this tragedy because people have to learn from the mistake, lah. Yeah. So this is what I can have to say. Yep.